Okay, class, so today on the conic section, we're going to be talking about the hyperbola. The hyperbola is developed when the intersecting plane in a parallel to the axis of the cone and touches both the napes and the double cone. Usually, what that means is like a smooth type of curve laying in a plane. It's defined by geometric properties or by equations for which it is the solution set. So if you look at a hyperbola in a as a smooth curve in a plane, usually it'll be the horizontal one. So it'll be a horizontal plane, like the graph, right? So some smooth curve laying in the plane. So it'd be smooth horizontally. Vertically would look like this. So it'd be like that. And then how they said like parallel to the curve of, so it would look 3D model would look like this. So this is basically what these are going to be this part of the plane. So since we already know how it looks, let's try to see if we can like put it into like mathematical terms, into paper. So let's start off with explaining the vertical and horizontal. So we have the horizontal hyperbola and the vertical one in the right. I had to cover the cheat sheet. So the equation corresponding to the horizontal is x squared over a squared over minus y squared over b squared, which equals 1. This is the case when the hyperbola is centered at the origin. So we gotta put centered at 0, 0. A is the distance from the center of the hyperbola and the vertex. So the center and the vertex. So we get the two vertices. So it'd be plus or minus a comma 0 for this specific hyperbola. And the same thing for the horizontal. So a is the distance from the vertex from the center of the hyperbola. So 0 comma plus minus a. And then the equation for the horizontal one would be y squared over a squared minus x squared over b squared, which equals 1. So when a squared is under x squared, it's gonna open left and right. Or when there's a positive sign of x squared. When there's a positive sign in front of y squared, it's gonna be up and down. And a squared is always under the positive. And then b squared is under the negative terms. Now the coordinates for the vertices for this hyperbola would be 0 comma plus or minus a. The coordinates for the vertical side would be f is parentheses plus or minus c comma 0. And then for the other one would be 0 comma plus or minus c. So these flip. The hyperbola, the full side, is going to be located towards where the hyperbola opens up. So f would be on the outside where it opens. And c units are going to face away. And the one in pink, it'll face away. So it's going to face away. And the same thing for this one. So c units face away and the f is going to be on the opposite side of the hyperbola. And the equation for the hyperbola would be c squared equals a squared plus b squared. In contrast, for the ellipsis, it's going to be c squared equals a squared minus b squared. Well, that would be the only difference. You got to remember that for the hyperbolas, it's a squared plus b squared. Excuse me. So the other thing we need to be familiar with is the transverse axis. So the transverse axis is the line segment that connects these two vertices from this point to this point. So the left of the transverse axis would be 2A. Same thing here. From here to here would be 2A. So horizontal and vertical transverse axis. Remember the distance between from the foci, the two focal points, is going to be 2C, because this one's half, this is the other half, so it'll be 2C. And this one would be 2A, because it's from here to here, 2A. So 2A for both sides, because it's 1A, C, so it's 2C. And then the formula for that would be y equals plus or minus b over a times x. And for the vertical hyperbola equals y equals plus or minus a over b times x. And this is only true when the hyperbola is centered at the origin. So that would be like the way for you to graph it. Fun facts that we have about the hyperbola. Usually when it's used, you can use it, the way that you might see it in the real world would be, it's called lunar navigation. Lunar navigation is usually used for fishing or for like looking for stuff under the water. So like, have you seen those scans where they find the Titanic, or when there's like a fisherman trying to find salmon in like those documentaries? Usually they use lunar navigation so they can like scan whatever's at the bottom of the ocean, and it beams and it pops back up and you see it in the graph. Another thing that that's a fun fact about this is that, you know, when you go out to eat and they say ding, order is ready, and they have like a little lamp and it's like the food is under it, so the one that's the server is going to take it to you, knows that the food's there, but the food is going to keep its warmness. The lamp there has a hyperbola, basically is a hyperbola, and keeps your, when the light's on, it will keep it warm. So that's why your food is always warm. That's a fun fact about hyperbolas. Other than that, I hope you enjoyed this, and I hope you learned anything from this.